Hello friends, welcome once again to our channel SR Pharma Gyan. Today I am going to discuss about one of the important rule in organic chemistry, that is Markonivkov Rule. So what exactly the rule states? Markownikoff Rule states this: if there is a reaction between an unsaturated asymmetric hydrocarbon with hydrogen halides like HBr, the negative part of the reagent will be attached to the carbon atom having fewer number of hydrogen. So if you consider this one, this is the negative element and this is the positive element of HBr. So the negative element will be attached to the carbon having fewer number of hydrogen atom. Here it is 1 hydrogen, here it is 2. So bromine will be attached to this carbon atom. So what is the product it is from? CH3. Similarly, the hydrogen will be going to that carbon atom, that's why it is CH3. So this will be the major product of this reaction. The another product, that is CH3CH hydrogen CH2Br, that will also form in the reaction mixture, but that will be the minor product. Okay, what is the condition? Asymmetric unsaturated hydrocarbons, reaction with hydrogen halides. So why asymmetric? What is actually symmetric and asymmetric? See that the bonded two carbon atoms here, this carbon atom is attached with two hydrogens, whereas this carbon atom is attached with one hydrogen, one CH3. So two different groups are there. Here this is one CH3 CH, here it is hydrogen and hydrogen. So they are not similar. So that's why this is asymmetric. So how we will call this symmetric? Suppose similar type of group is if it is attached, then it is symmetric. So Markownikoff rule, why it is not applied in symmetric? If you see that the reaction, it's going to give you the same product. If bromine is attached to this carbon atom, so what it will form? Correct. If bromine is attached to this carbon atom, what it will form? If you see, both are similar product, same product. So that's why there will be no difference. There are two products will not going to form. That's why this Markownikoff rule is not applicable in symmetric unsaturated hydrocarbons. Now the next part comes, that is the electrophilic addition reaction. It's a electrophilic addition reaction. So what is actually electrophilic addition reaction? See that this is a double bonded carbon atom, whereas there will be a pi cloud. That means always the positively element charge will be attacking first, because positive will be attracted towards the bonded electrons. Okay, so this is electrophile. So in the mechanism, the electrophile first attacked with the pi cloud. That's why it is a electrophilic reaction. Now why it is an addition? See that two molecules are reacting together to give you one molecule. So that's why an addition reaction. This is an addition reaction. So this addition reaction is possible due to the presence of this double bond. This double bond breaks. Here it forms one single bond, whereas the remaining valencies will be absorbed by the other reactants. So that's why it is an addition reaction. Now coming to the next important part of this Markownikoff rule. To understand the mechanism, you need to understand this part, that is stability of carbocation. See that carbocation means C+. So if 3 carbon atom is attached to that carbocation, then it is tertiary carbocation. If 2CH3 is attached and one is hydrogen, if 2 carbon is attached, then it is secondary. And if one carbon is attached and remaining are the hydrogens, then it is primary. Now we need to understand the stability of this carbocation. See, any charge that is applied in any molecule or any atom, that makes the atom and molecule unstable. That means the presence of this carbocation, the positive charge, that makes this molecule unstable. So if you could able to reduce this positive charge, we can stabilize it. So how we can reduce it? By applying some negative charge. We all know that CH3 is a electron donating group. It donates the electron. So here if we find that there are 3 CH3 atoms, molecules are there which are donating electron. That means more amount of positive charge is going to be neutralized as 3 CH3 is attached with that. Whereas here 2 CH3 is neutralizing this positive charge. So the more neutralization we can get in tertiary rather than secondary and primary. So less charge in carbon, more reduction or more neutralization of this positive charge will give you more stability. So that's why tertiary carbocations are more stable than that of secondary and than that of primary. So this concept actually give you an explanation why the Markownikoff, the molecules are following the Markonivkov rule. Let's come to the mechanism. So the reaction between this occurs in three steps. The first step that involves is the formation of electrophile. So here what happens? Each bears, it undergoes heterolytic cleavage and it gives H plus and Br minus. As bromine is a negatively charged element, the bonded electron will be transferred to bromine and the bromine will get a negative charge, whereas the hydrogen will be getting the positive charge. This is the formation of electrophile. In the second stage, attack of electrophile to the unsaturated carbons. So this electrophile, this CH3, CH2, it will be attacked by H plus ion, and this H plus can attack either in this carbon atom or in this carbon atom. So if the attack occurs, what are the products we are getting? CH3, CH, if hydrogen is attacked, that this bonded electron will be transferred here because this is H plus. So this bond will form by taking these electrons, these double bonded electrons, and this CH2 will get a positive charge. If this hydrogen attacks this element, what will happen? CH3, CH plus CH3. So here the hydrogen will attack this one. So here the bonded electron will be transferred to this carbon atom. Okay, so this is going to happen. Now if you find here, this is the positive charge occur in a carbon atom which is attached with one carbon atom. So this is a primary carbocation. Here the positive charge is with the carbon which is attached with two carbon atoms. So this is secondary. As we have discussed right now, that secondary carbocations are more stable than primary carbocations. So this product will form in less quantity, and this product will form in more quantity. So that will be the major carbocation, and this will be the minor carbocation that is going to form in the product. Now what happens in the next step? The nucleophile, that is Br minus, that formed, attack the carbocation. That means the CH3, as it is formed in the more quantity, the bromine will attack that carbocation. So what is the product is going to form? CH3. So ultimately we can say the negatively elements are of the reagents is going to attach with the carbon atom which are having fewer number of hydrogen. So this will be the product. Now let's discuss about the reactivity of hydrogen halides. So if we say HX, that indicates some hydrogen halides which are HI, HBr, HCl and HF. Now if you see that this hydrogen iodide, it is having, iodine is a bigger molecule. So the bond length between these two is quite big. Whereas for hydrogen bromide, the bromine is little smaller than that of iodine. In case of chloride, it is more smaller than the bromine. Whereas for hydrofluoric acid, it is the smallest one in this series. So the bond length, if you consider the bond length, this is small, this is bigger. Okay. As we know, the bond strength is inversely proportional to the bond length. That means more bond length will be less strength of that bond. So this is considered to be the strongest bond among the series, and it is quite difficult to break. Whereas for these elements, it is very easy to break this bond. So ultimately in this reaction, the reaction between unsaturated hydrocarbons HI, HBr and HCl actively participate in this reaction, whereas HF does not involve in this reaction because due to the high strength of the bond, this will not get dissociate, and that will not involve in this reaction. So the reaction between unsaturated compounds and HF is quite minimum, whereas this HI, HBr and HCl readily react with the unsaturated hydrocarbons. Now one question comes in that whether it is applicable only in case of HBr or any other elements can also give this type of reaction. So if you take an example of reaction between an asymmetric unsaturated hydrocarbons with hypohalous acid, that is HOBr, what will happen? So there is a change in that HOBr polarity. If we take this molecule, the bromine get positive charge, whereas OH get negative charge. So ultimately the product, what is going to form, the negatively charged elements is going to attack the carbon which is having less number of hydrogen. So what will be the major product in this reaction? CH2Br. The similar thing also we can observe in case of the reaction of H2SO4, whereas H plus it acts as a positive and HSO4 it acts as negative. So if we are reacting with this unsaturated hydrocarbons with H2SO4, so the negative part is HSO4 minus and positive part is H plus. So this negatively part elements is going to be attached with that. What the product we are going to get? CH3, CH, HSO4 plus CH3. So this all about the Markonivkov rule. We are going to discuss about anti-Markonivkov rule in another reactions. The link of that video I will be giving in the description box. So if you want to find the nomenclature of these compounds, how to go for nomenclaturing of the products, I am having a separate video for all type of nomenclatures. You can also follow that video for finding the nomenclature of organic compounds. Thank you very much for listening. Have a nice day.